Hello and welcome back to Math with Mrs. Becker. Today we are looking at Algebra 2 and we are finishing up our Chapter 2, Section 1. Today we will look at inequalities. Now an inequality just means that two values, you're not saying that they are equal. So they include things like the less than symbol, greater than, less than or equal to, greater than or equal to, or simply just saying it cannot equal. So inequalities include any of those different values. As we go ahead and solve inequalities, the properties of equality are true for inequalities as well. What that means is that what you do to one side of an inequality, you must also do to the other. There is one important rule. If you multiply or divide both sides by a negative number, so if you are trying to solve for a variable and you end up multiplying or dividing both sides by a negative number, you flip the sign. So for example, if it was a greater than symbol, if you ended up multiplying both sides by -2, in the process, your symbol would have to flip, okay? So visually, this is what that would look like. We have the statement 4 is less than 6. Well, if you multiply -2 here, they're saying what you do to one side, you have to do to the other. So if I multiply -2 here, you also have to multiply -2 here. I'm multiplying both sides by a negative. So what happens, notice the sign flipped. It was a less than symbol. When you multiply both sides by a negative, it changed to when you multiply both sides by a negative, it changed to a greater than symbol. 4 times -2 is -8. 6 times -2 is -12. So the big thing is, if you ever multiply or divide both sides by a negative, go ahead and flip that sign. Let's do this. They want us to solve and graph. If I look at this side, there are no parentheses, no like terms. If I look at this side, no parentheses, no like terms. So I go ahead and I look and I notice that I have variables on both sides. You can't have variables on both sides. So if I look at the number, I like to play weakest link like we talked about yesterday. 8 has a lesser value than 13. So you are the weakest link, goodbye. I minus that 8a to the other side. What I have remaining is -2. That's greater than or equal to 13a minus 8a is 5a. You still have plus 8. What I'm trying to do is solve. Solve means to get the letter by itself. I need to go ahead and get rid of my plus 8 by minusing 8 to the other side. I had -2. If I minus 8 more, it's like it's -2 degrees outside and it drops 8 more. We're at -10. Divide both sides by 5. Here I do not flip the symbol, because what I'm doing is I'm dividing both sides by a positive. The symbol stays. -10 over 5 is -2 is greater than or equal to a. If I am graphing, if you have a greater than or less than symbol, that is an open circle on a number line. If you have greater than or equal to, less than or equal to on a number line, that is filled in. Now, very often, people are more comfortable with the variable being on the left side. Here we have it on the right side. We can rewrite this as long as we make sure that we keep the inequality so it's opening to the -2 and pointing at the a. So I can say a, remember it's pointing to the a, opening to the -2. If you are more comfortable with it being like this, totally fine. If you're fine either way, you could have left it. If I'm graphing, I have a -2. This means that a is less than or equal to -2. So on -2, I have a filled in circle. Now your number line, that represents the values that you are looking at. We are looking at values that are less than or equal to -2. Less than, you go to the left and you draw an arrow. So that would be it. We get the letter by itself, show graphically what that looks like on a number line. Let's go again. I don't have any parentheses or like terms. I don't have any parentheses or like terms. I do, however, have x's on each side. This x, because it does not have a coefficient, that is an unwritten one. If I go ahead and I minus 1x to each side, this would be canceled. Positive 8 remains, greater than or equal to. I had 4x. If I minus 1x, I'm down to 3x plus 17. I need to get x all by itself. On the same side of the inequality as x, but not connected, is a plus 17. So I need to minus 17 to the other side. If I have 8 and I minus 17, I get a negative 9. Now, I'm still not done. I'm not done because I need x all by itself. To cancel the 3 that's being multiplied, you divide both sides. Again, I don't have to flip the sign because what I'm dividing both sides by is a positive 3. Negative 9 divided by positive 3 is negative 3. It's greater than or equal to x. Again, if you're more comfortable with the x on the left side, you can go ahead and write it. Now you graph it. We have a negative 3. That's the number that we're basing this all off of. That negative 3 is included because it's less than or equal to. X is less than, so that means that we are including values that go to the left. Just one more example. Crazy. Short notes today. Okay, if you have something like this, just like we looked at in the first part of 2.1, I'm going to go ahead, you just look at one inequality at a time. On this side, I have to go ahead and distribute. You always simplify first if you can. And remember, simplify, you have 2 steps. Cancel parentheses, combine like terms. My negative 18d is fine, plus 5 times 8 is 40, plus 5 times 3d is 15d. There is my symbol. I can combine like terms because negative 18 and 15, they both have a d. Negative 18 plus 15 is negative 3d plus 40. There's my symbol. It's less than or equal to. Now I look at the other side. I have parentheses, so I need to go ahead and distribute. 7 times 3d is 21d. 7 times negative 8 is negative 56. Okay, so now I have this. No parentheses and no like terms on each side when you look at them separately. So now it's time to look and say, all right, well, I see that I have d's on both sides, okay? Just to make sure that I can show you one where we have to divide by a negative, I'm going to move the 21d. This is a positive 21d. If I minus 21d, that'll cancel. Negative 3 minus 21 more. This is like I borrow $3 from you. Now I borrow another 21. I'm in the hole $24. Plus 40 is less than or equal to 56. If I want d by itself, I need to minus 40 to each side. So I'm just going to come right down here. I have negative 24d less than or equal to negative 56 minus 40 is negative 96. To get d by itself, I need to divide both sides by a negative 24. Now here is an example of where you would have to switch the signs. What I'm doing is I'm dividing both sides by a negative. So in this process, my symbol has to flip directions. Negative cancels negative, 24 cancels 24. So d is greater than or equal to negative 96 divided by negative 24 is positive 4 because negative divided by negative is a positive. Now if I go to graph this, 4 is the number that I will have a circle on. Again, this is a filled in circle because it's greater than or equal to, so it includes that 4. D is greater than, so you shade to the numbers that are larger than 4, meaning you go to the right. That is the second part of 2.1. Big picture is we just changed the equal sign to greater than, less than, greater than or equal to, less than or equal to. When that happens, your solution is no longer just one value. This is a range of values. This means it starts at 4 and it includes any value that's greater than that. That's why we go ahead and graph on a number line, because this allows us to visually show the numbers that would make this statement true. Your assignment, there's just 9 questions out of the book. You'll go to page 94, 95, try 18 to 20, jump ahead, go 37 to 39, and then 44 to 46. Hope you're having a great day. Talk to you soon.